Today we will be discussing dimensional analysis. Dimensional analysis is a method of organizing a math problem that allows for unit cancellation. We're going to start out just directly with the problem. So the first problem that we are going to work states how many meters are in 237 miles. As you can see, I've color-coded the problem, and that's because it's going to help us see exactly where we are plugging into our equation that we're forming. So how many is going to turn into x, because that's how we ask questions in math. We say x rather than a question mark or how many. Then we have meters being shortened to its symbol, m, and we have rn turning into equals, and then we have our number given in the problem, which is 237 miles. That miles is shortened to its symbol, mi. So how many meters are in 237 miles turns into x meters equals 237 miles. Now that I have my actual equation, what I'm going to do is I'm going to find some conversion factors that will help me solve this problem. I see meters and I see miles. I do not know the direct conversion between meters and miles, so that means I need a step through. What I'm going to step through is kilometers. So since I know the relationship between meters and kilometers, 1,000 meters being equal to 1 kilometer, and I know the relationship between kilometers and miles, 1.6 kilometers being equal to 1 mile, I can go ahead and utilize those conversions to help me get where I need to go. These conversions in this particular orientation, though, is completely useless to me. I need them in what is referred to as fraction style ratios. They are fraction style because they look like fractions, but they are ratios. They are not true fractions. So just like I could say, for every 1,000 meters, there is 1 kilometer, I can also say for every 1 kilometer, there is 1,000 meters. Again, these are ratios. These are not fractions, but they are equal to each other because they are just reformatting this statement up here, which is an equivalency. So I have fraction style ratios for both of my conversions, and I can go ahead and move forward into picking versions of my conversions that will allow me to cancel my units. How this is going to happen is I'm going to look at my initial setup and I'm going to find what will allow me to cancel. I'm currently in miles, and to cancel anything, if I'm going to be dividing, I need miles to be on the bottom, so that means I will choose this conversion factor. So I have this dimensional analysis set up. These are how my dimensional analysis look. These vertical and horizontal lines are sometimes referred to as train tracks. Okay, so my dimensional analysis train tracks are set up so that I can cancel out my units. I started with x meters equals 237 miles. Since miles is on the top of my dimensional analysis, I need to pick the conversion that has miles on the bottom. That's my purple version. When I plug in my purple version, I'm able to cancel out miles since it appears at the top and at the bottom of my fraction. And I'm left with the unit kilometers. Kilometers is not the unit that I wanted. I wanted meters. I did not want kilometers. So I need to look at my other set of conversion factors and go ahead and find the one that will allow me to cancel out kilometers. This is going to be my blue version. So I went ahead and I plugged in my blue version of my conversion factor, which allowed me to have kilometers on the top and on the bottom, which meant they could cancel. And it left me with a single unit, which was meters, which was the unit that I said that I wanted. After all of that, what I'm going to do is I'm going to look at this train track set, and I'm going to see exactly what is happening here and what these vertical lines and horizontal lines mean. Instead of kind of clunking it up and making my math look ugly, I've gone ahead and streamlined this. So instead of a bunch of parentheses or a bunch of X's and blah, 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 and making it look all ugly, I've streamlined it so it looks nice and pretty, and I've created a code. Everybody knows this horizontal line as divide. It's very common in math, and you've used it several times over your educational career. Well, what's the opposite of divide? Multiply. What's the opposite of horizontal? Vertical. So my vertical lines in between here are representing my multiplication between the conversion factors. This means I'm just going to have to multiply across the top of my dimensional analysis, and I will divide by the bottom. So that would be, in the calculator, I would type 237 times 1.6 times 1,000, and then I'm going to divide by everything on the bottom. So I will divide by 1, and then I will divide by 1 again. Just because this particular example has me dividing by 1 does not mean that I will always divide by 1, or that my conversions will ever have, or will always have 1 on the bottom. Just so happened to happen for us this time, but don't get too comfortable about that happening every single time. After I plug this into the calculator, the number that I got out of my calculator, I have to write down every single number that comes out. Even if it's really long and really big, we have to write down every single number. The reason we write down every single number is so that we know you are not hiding anything when you round to the appropriate number of sig figs. This time, I got a pretty nice number. It was 379,200. Pretty nice, pretty round. However, this is not the appropriate number of sig figs. I need to round to my appropriate number of sig figs. Where do I find the sig figs? How do I know how many sig figs I need to look for? You need to go back to your original problem. In your original problem, you will have a number given. That number given is the only place that you can pull sig figs from. The only number in this entire problem was 237. 237 is all non-zeros, and that means that they are all significant. So 237 has 3 sig figs, which is how I knew that I would be rounding my number to 3 significant figures. So 3 significant figures, 1, 2, 3. That 9 is the last number that I care about. I'll look over to see if I need to round that 9 up. That 2 does not make me round up, which means that I will just drop it, but I will leave a 0 in its place as a placeholder so that it maintains value. So 379,200 is going to change into our final answer number of 379,000. This number is naked, however. I need to attach my units, and those units are going to make my number appropriate for public viewing. I am able to find my units either in the actual words of the problem, but who wants to read anyway, or next to my x. I see that next to my x I have the symbol for meters, so I am just going to go ahead and attach that symbol meters, which would make my final boxed answer 379,000 meters.